Every population in Western Europe carries Bronze Age steppe DNA except one. The Basques' genetics match no surrounding group. Their language connects to nothing on Earth. What scientists uncovered in their DNA may force us to rethink European history entirely. Tucked between the Bay of Biscay and the rugged slopes of the Western Pyrenees, the Basque Homeland forms a compact region that straddles the border of northern Spain and southwestern France. This territory, measuring about 15,800 square kilometers, is home to roughly 3 million people. The Spanish provinces of Alava, Biscay and Guipuzcoa make up the core, joined by Navarre to the east and the French Basque areas of Labourd, Basse-Navarre and Soule just across the border. Despite its modest size, smaller than many European regions, the Basque country stands apart as a distinct cultural and demographic zone. The OECD and National Statistics Offices count over 2.2 million residents in the Spanish Basque provinces, nearly 650,000 in Navarre and just over 300,000 on the French side. This patchwork of valleys, coastal towns and mountain passes sits at a crossroads of Europe, yet it has maintained a striking cohesion over centuries. In a continent shaped by constant movement and mixing, the Basque region's sharp boundaries invite a question. How has such a small population in such a busy corner of Europe remained so distinct? Euskara, the language spoken by the Basque people, stands alone in Europe. Linguists and language atlases, including UNESCO's Global Survey, classify it as a language isolate, meaning it has no proven relatives among the Indo-European tongues that dominate the continent. The earliest known inscription in Euskara dates to the 7th or 8th century, yet its roots run far deeper, predating the arrival of Latin, Celtic or Germanic speech. Decades of scholarship from Coldo Mixelena to Larry Trask have tested every proposed link. None have held. As Trask wrote, no evidence connects Basque to any other known language family. This independence is not a matter of dialect drift or lost records, but of a language whose structure, vocabulary and syntax resist all attempts at classification. In a region shaped by waves of migration and conquest, Euskara's persistence raises a profound question. What allowed this ancient tongue to survive, unchanged and unmatched for thousands of years, when every surrounding language was swept away or transformed? Inside the Oxford Ancient DNA Lab, researchers start with a handful of teeth and bone fragments from Neolithic and Mesolithic burials across the Basque region. Each sample enters a clean room where technicians extract and sequence the fragile genetic material. The goal is to reconstruct the ancestry of living Basques by comparing their DNA to that of long-dead ancestors. The team runs the results through a statistical model known as QPADM, a tool that estimates how much of a population's genome comes from various ancient sources. For the Basques, the answer is strikingly consistent. Nearly 90% of their ancestry traces back to two groups: early European farmers who arrived from the Near East about 7,000 years ago, and Western hunter-gatherers, the descendants of Ice Age survivors who hunted and foraged in the forests and valleys of prehistoric Iberia. Steppe ancestry, which swept into most of Western Europe during the Bronze Age, barely registers. In the Basque genetic profile, it accounts for no more than 3%, a fraction compared to neighbouring populations. The numbers produced by QPADM are not just abstract figures. They provide a kind of genetic fingerprint, revealing a population that has remained largely untouched by the great migrations that reshaped the continent. For scientists, these results raise a new set of questions. How did the Basques maintain such continuity, and what does it mean for our understanding of Europe's deep past? Across Western Europe, the Bronze Age left a genetic legacy that is nearly universal. Ancient DNA studies show that as the steppe herders moved westward around 4,500 years ago, their genetic signature, often called steppe ancestry, became woven into the DNA of nearly every population from Portugal to Poland. Today, the average Western European carries at least 20% steppe-derived ancestry. In many regions, that figure climbs to 30% or higher, but the Basques are a striking exception. Multiple genome-wide analyses using principal component analysis and formal admixture modelling consistently place modern Basques outside the main European cluster, a visible outlier on the genetic map. Their steppe-derived ancestry rarely exceeds 3%, a fraction of what is found in neighbouring Spanish, French, or even Catalan populations. The question is not just why the Basques are different, but how this enclave resisted the genetic tide that swept across the continent. In a land defined by movement and mixture, the Basques' genetic profile remains a rare case of near continuity, raising new questions about the forces, geographic, social, or cultural, that preserved their distinctiveness. Modern Basque DNA carries unmistakable traces of long-term isolation. Blood group studies reveal an Rh negative frequency of about 30%, double the rate found in neighbouring populations and the highest recorded anywhere in the world. This rare trait, once scattered across prehistoric Europe, now stands out as a living clue to centuries of endogamy and genetic drift. On the paternal side, over 80% of Basque men belong to the R1b p312Y chromosome lineage, a branch that dominates Western Europe, but is unusually homogeneous in the Basque region. Mitochondrial DNA tells a similar story. The H1 haplogroup, common among early European farmers, remains heavily concentrated in Basque maternal lines. These patterns reflect the founder effect, a process where a small isolated group amplifies rare genetic features over generations. In the Basque country, the result is a biological fingerprint that preserves signatures of ancient ancestry while resisting the sweeping genetic changes that transformed the rest of Europe. During the last ice age, the Pyrenees and the Cantabrian coast offered a narrow refuge from advancing glaciers. Archaeological records from sites like El Mirón cave in northern Spain reveal a line of human presence stretching back nearly 19,000 years. Yet the genetic trail is incomplete. No direct genome from a Paleolithic Basque has been sequenced. The mountains stand as silent witnesses, preserving clues to survival and isolation, but leaving a gap that future research still hopes to fill. Science maps our genes and languages, yet the Basques remain an outlier, proof that Europe's past holds secrets even ancient DNA can't fully unlock. Some mysteries still endure in plain sight.